So today we continue with properties of line segments. Today our goal, I can find the length of a line segment if I know the endpoints of the line segment. So yesterday we did work with midpoints. Today we're taking a look at the length. So this first question we're going to do, draw the line segment with endpoints A, which is 2, 1, and B, which is 4, 6. So I've got a point at 2, 1, so that'll be point A. And that's 2, 1. And then I need point B, which is 4, 6. So that's B, and that's 4, 6. We'll draw that line, and remember, like yesterday, this is a line segment, so we don't extend it through the points. It stops at each end there. Now we're being asked to draw a right triangle that has AB as its hypotenuse. So I'm going to draw a line across the bottom here and a line on the vertical here, and that's a right angle triangle. And the hypotenuse of that triangle is the side AB. Now, we're going to just come up with a number for the length of the horizontal and the vertical lines we just drew. So the horizontal line across the bottom here is 2 units, and the vertical line going up the side is 5 units. So here I'm going to put 2, and I'm going to put 5 for the horizontal side and the vertical side. Now we're going to use Pythagorean theorem to try and find the length of AB. So I'm trying to figure out what AB is. So AB squared equals, and remember, we're looking at a right angle triangle here, so it's like A squared plus B squared equals C squared. So the horizontal and the vertical side are our 2 shorter sides. So that's going to be 2 squared. That's going to be 5 squared. We get 4 plus 25 when we square those. So at the end, remembering back to Pythagorean theorem, we would take the square root of 29 to get the value for AB. And if we rounded that to 1 decimal place, the length of that line would be 5.4 units, which makes sense because it should be the longest side, and it's longer than the other 2 sides that we have. Now, notice the coordinates of the endpoints. So our endpoints are 4, 6, and 2, 1. If you subtract these two, so if I do 4 minus 2, so if I subtract, 4 minus 2 is equal to 2, and 6 minus 1 is equal to 5. And so when you're actually, you're trying to find the lengths of those sides, the length of the horizontal and the vertical side that we drew, to get the horizontal side, which was 2, we are subtracting those 2 values. So x2 minus x1 gave us that 2. And for the vertical side, we do y2 minus y1, and that gave us our 5. So what that means then is, so we don't have to draw the line every time to find these. We've got a little bit of a formula here, because here's what we knew from up above, that AB squared equals the horizontal side squared plus the vertical side squared. And as we just found out up above, the horizontal side is x2 minus x1. So that would be squared. And the vertical side we can find by doing y2 minus y1, and then that's going to be squared. And then think about what we did on our last step up here when we were solving for AB. We took the square root of that answer. So our formula then actually looks like that. So AB is the square root of x2 minus x1 all squared plus y2 minus y1, and then that's all squared. Okay, so let's look at a couple of examples here and see how that gets used. So in example 1, find the length of the line segment with endpoints B, which is negative 6, 5. I'm actually going to plot that on here. Negative 6, 5. So that's B, negative 6, 5. And C, 4, negative 3. So there's C, which is 4, negative 3. By both graphing and by using the formula you developed in the previous question. Does the formula. So we're just going to double check and see if the formula does in fact work like we suspect it does. So that's what we're trying. So we'll do it with the graphing first. So if I'm working with the graphing, I need to know the length of the horizontal side here and the length of the vertical side here, so I can use Pythagorean theorem. So in this case, I'm trying to find BC. So it's like BC squared equals the horizontal side squared plus the vertical side squared. So the horizontal side here, if I count my way across here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 10 squared. And if I count across or count up the vertical, I end up with 8 for that. All right. So now when I figure those out, 10 squared plus 8 squared, I get 164. So once I take the square root of 164, if I round that to one decimal place, I get BC is about 12.8. So again, that's the longest side. That makes sense. So that's the graphing. Now let's just jump over here and try it using the formula. So if we use the formula, we're trying to find BC. So remember, we subtract the x's and square it, plus, and we subtract the y's and we square them. All right, so it might be helpful to write the 2 points one over the other. So a lot of times in these formulas, it's just helpful to write the 2 points like that. So you're putting the right numbers together in the formula. So on my next line here, I can do x2 minus x1. So 4 subtract negative 6 is going to be 4 plus 6 squared. And then I'll do negative 3 subtract 5 squared. It is important that you go in the same order. So if I'm going to go 4 subtract negative 6 in this first bracket here, then I have to do negative 3 subtract 5 in the second bracket. If I go in the opposite direction for one of those, then it's a problem. So let's see what happens next here. So I think we're going to get some familiar numbers here. So we get 10 squared plus negative 8 squared. Now remember, when we square negative 8, we're going to get a positive answer. So in the end, we actually end up with that exact same 164 underneath the root sign. So the formula actually gives us the exact same answer. Okay, so I will run through these two guys, and then I think we'll do example 3 as a warm-up tomorrow. So here I've got AB equals okay, so for AB here, so I'm going to go in this direction. So I'm going to do 5 subtract negative 2. So that's going to be 5 plus 2. And then I have to go 7 minus 4 in the second bracket. So we end up with 7 squared plus 3 squared. So AB is the square root of 58. And if we round that to 1 decimal place, the length of AB on a graph would be 7.6 units. And once you get the hang of this formula, it's quite straightforward. You just need to be careful that you pay close attention to detail so that you don't make a mistake with a sign or adding or subtracting things incorrectly, because that's kind of the drag when you understand what you're doing but you just make a careless error. So do be aware of that. So this time I'm going to do 7 minus 5 for my x's. And then for my y's, it's going to be negative 11 minus 0. So I'm going to have a positive 2 squared plus a negative 11 squared. That's going to give me the square root of 125. And I figure that out underneath the root sign. And that's equal to approximately 11.2 units there. Okay, so as I said, example 3 we'll tackle tomorrow as a warm-up. Thanks.